जी सर, आवाज आ रही है ना मेरी?
Yes, sir.
Okay. I give the brief introduction about the today's webinar. Now, welcome to everyone. Thank you for going us for the today's webinar. Myself, Mehul Padiyar, working as a lecturer in Parul Institute of Engineering and Technology Diploma Studies. The Parul University is the leading provider of the innovation and graduates. Parul University gives the opportunity to our students and the great the knowledge about the various fields, the present scenario, and recent innovations. Today we are presenting a webinar. The title is Recent Trends on Computer-Aided Manufacturing. In short, CAM. Today's speaker of our webinar, Mr. Ruchir Desai. Ruchir Desai sir is working as an assistant professor in ADIT. He is a concern with the CVM University, Vallabhbhai. Sir have a vast experience about the computer-aided manufacturing and computer-aided design. Sir take the presentation regarding the computer-aided various programming, how to computer-aided manufacturing done, and sir also give the brief introduction about the various processes occurs during this sessions. During this session, if anybody have any query regarding this topic, they contact with us. My mobile number is 9909212705. It is mentioned in the our Facebook links also. So without the spending time, I hand over the session to Mr. Ruchir Desai sir, and thank you very much, sir, to take the session, sir.
Hello, am I audible?
Yes, sir.
Okay, okay. So, thank you very much. Once again, I am just giving my introduction. I am Ruchir Desai, working as an assistant professor in Mechanical Engineering Department in ADIT. It is the one of the college of CVM University. First, I would like to thank Mehul sir for inviting me for an expert lecture on this platform. Today, I am going to discuss about the recent trends in computer-aided manufacturing. Here, I am going to talk about the computer-aided design and its importance, computer-aided manufacturing and industrial revolutions, what's going on in industry 4.0, we will discuss. We will also discuss about the flexible manufacturing system and additive manufacturing, which is 3D printing. And also, I would like to show you the AICT Idea Lab related components. So let us start our discussion. Sir, my screen is visible?
Yes, sir.
Okay, okay. Thank you, sir.
Sir, wait a minute. I think in a Facebook Live is not working. So, sir, wait a minute. Hello. Jiten sir, hello.
Yes.
I called to be webinar. Hello, Jiten sir. Yes, sir. Ruchir, sir. Please continue, sir. Ruchir, sir.
Yes, sir.
Yes, please continue, sir.
Okay. So let us start with the computer-aided design. So what is computer-aided design? So as we all know that it is the use of computers, right? Or we can use the computers to assist the creation, modification, analysis, synthesis, and optimization of a design, right? Now, traditionally, the design process has these 6 steps. Number one, we need to recognize the customer needs. Then we need to identify, then we need to give the problem statement or problem definition that this is the problem of our customers. Then we need to synthesize, then we need to analyze, optimize, and this whole process is done using the pen and pencil, right, on the pages. Then we need to evaluate and we need to represent the idea, the concept, and the design to all the customers. Then after we can manufacture it. But now with the use of computers, how this design process changes, let's see. So first 2 steps remain same, but third step has been changed, and now the new step is geometric modeling. We need to create the drawing of the product that we are going to develop into the CAD software. We need to use the one of the CAD software. Then after, we can use the analysis software to analyze the geometry or the product under the condition of different loads and boundary conditions, so that we come to know either the design product is sustained or not under the application of various loads. Then we need to review the design and evaluate the design. And lastly, we need to automate the drafting. Means we need to develop the drawings, front view, side view, top view, right, for the manufacturing engineers. So before computer, how the industries were looks like, or what are the actual process for design and manufacturing. First of all, the engineers has to draw the sketch using the pencil, a rough sketch, uh, as you can see on the screen. Then engineer has to develop this 2-dimensional sketch in a detailed view, right, which includes the material properties, tolerances, and everything. And lastly, the manufacturer engineer has to manufacture it. So this was the procedure. But nowadays, or this is just a image which shows how the design department of any industry was look like, right, before the era of computer. But now, with the use of computers, we need to develop the CAD model or solid model of the part, which will be used for engineering drawing and then manufacturing. This CAD model is also used to analyze the object, analyze the product under the same environmental conditions, and we can directly use this CAD model to produce the part or CAM. Right. So CAD model is a starting point. Nowadays, it is a starting point of everything. So this is the image which shows how the design department or the design engineers in various industries looks like. Right. This is how the design engineers works. Now come to today's topic, that computer aided manufacturing. Once we have the drawing of particular product, particular part, then we can use the computer again to plan, to manage, to control the manufacturing operations. We will use computers for the direct and indirect interface with manufacturing machines. Further, what is CAM? So, use of computers for non-design activities, right? But in manufacturing process is known as CAM, computer-aided manufacturing. So, these are the steps we need to consider in computer-aided manufacturing. First of all, we need to develop a plan, process plan, then scheduling. Then after, we need to program using G code or N code in numerical control as well as industrial robots. And lastly, the quality control and inspection also can be done by computers. So, this is how the concept or idea has been converted to the physical reality. So this is basically the transformation of the concept from one form to another form. In the world of manufacturing, computers have played a vital role in taking product idea from concept to physical reality. Right? Moreover, the ability of CAM to reduce the time required to design and develop the prototype without reconfiguring the overall production line of the specific industries, which is embedded the CAM solutions in many industry verticals, right? CAM is now taking on a wider role in all operations of a manufacturing plant, including, as we have discussed, planning, management, transportation, storage. Further, let us move towards the industrial revolution. In how industry is changing from 18th century to 21st century. In first industrial revolution, steam engine were used, steam power were used for mechanical production, moving away from cottage industries, right? In industry 2.0, in 19th century, electricity comes into the picture and everything is transformed from steam power to electrical power. Electrical engines are there. Mass production and assembly lines were started in 19th century. Then in industry 3.0, in the mid 20th century, ICTs and electronics comes into the picture. And these circuits have used to automate the production lines and have created the networks for the manufacturing industries. And in today's era, in Industry 4.0, we are using, or industries have used, the advanced robotics. They are using 3D printing, Internet of Things, big data, artificial intelligence to develop their products. Here, we need to use the intelligent, flexible, and distributed production system. So we will see some of the points of Industry 4.0, how we are using IoT, artificial intelligence, cloud, big data in today's manufacturing industries. So this figure represents how Internet of Things have captured the manufacturing industry because of its 7 benefits. We can use inventory management, digital industries, smart packaging we can do, productive maintenance we can perform with the real-time data exchange. We can use smart material. We can enhance the safety as well using Internet of Things system. Then after, blockchain is also one of the advanced technology comes into the picture for manufacturers, which is used to secure the distribution of the data. In IoT, we are collecting the data, real-time data. In blockchain, we are securing and distributing the real-time data. In blockchain, we can track and record all the production steps included to develop one particular product, so that we can easily audit it. We can identify where is the when the maintenance is required, or where is the fault is that, or where the fault may occur, right? So we can prevent the failure. In augmented reality, it is the combination of the data obtained in IoT and distributed from the blockchain and the human intelligence. It is used to visualize the current scenario of the product. What is going on in the industry, one can easily visualize using the augmented reality. Fourth pillar of Industry 4.0 is artificial intelligence. Using all the systems which are capable of taking decisions by oneself are used. Fifth one is a cloud computing. Whatever data we are obtaining from Internet of Things, we can store in cloud, so that the CEO or the engineer or the manager of the plant can easily track or visualize into the data what happened in their production line in their industries. So this would be very easy for the owner of industry, right? That what happened, what's going on, how we can prevent the failures, right? So this is the overall picture, how the industry is going to change in upcoming years. Further, this schematic diagram represents how cobots, computer visions, artificial intelligence, and augmented reality will come together and work. From raw product to its development, to its production of various assembly lines, assemble it, and then how to package it, and then we can put it into the warehouses. Storage. All all of the things we can do in Industry 4.0. Further, Industry 4.0 in computer-aided manufacturing allows us the flexibility. Efficiency we can increase. We can increase the real-time communication, the gap between the machine and the man, we can reduce. We can enhance the safety and security in computer-aided manufacturing. So these are the two production lines. Nowadays, robots or cobots are used in automotive industries. You can see in this GIF. Further, this is the survey conducted by the Mordor Intelligence, which shows the growth rate of computer-aided manufacturing market around the world. The green area represents the mostly Asian countries, which is having the high growth rate for the computer-aided manufacturing market. And we know that the computer-aided manufacturing or design market has been captured by some of the major players, namely Autodesk, SolidCAM, CNC, Softwares, Siemens, and Dassault System Solutions. And many more players would come into this computer manufacturing field, including all the technology that we have discussed earlier. So this would be the very promising technology for the upcoming days. So as a part of the flexible manufacturing system in ADIT, in CAM lab, we have one setup, which includes CNC lathe machine, milling machine, which is connected to the computer. We also have the automated storage and retrieval system. Everything is connected using the AGV, automated guided vehicle. From the system, storage system of raw material, AGV will take the product, raw product, move towards the first machine using the robotic arm and the CNC lathe machine. Some operation would be conducted on that part. Further, AGV will move ahead and the remaining operations would be conducted on milling machine using the 5-axis industrial robot. Then again, AGV with the complete product, with the complete developed product, come to the inspection system, which we have installed the cameras, and everything would be powered by a compressor. By using computer, we can identify whether the raw product has been converted into the final product or not. And each and every machine, including AGV and robotic arm, has been guided by computers only. This is the AGV, this is the CNC machine, this is the 5-axis robot, this one is a milling machine, this is the camera, and this is the ASRS system. Let us see one video of all this system, how it works.
Hello everyone. A.D. Patel Institute of Technology Mechanical Engineering Department welcomes you all to introductory session of Computer Aided Manufacturing Lab.
Mehul sir, can you the screen is visible?
Yes, sir.
Okay, and it is audible, right?
Screen is visible and sound is audible. Sir.
Okay, thank you, sir.
We have high-end automated equipments like automated storage and retrieval system, CNC turning center, CNC machining center, Fanuc make 5-axis robot, automated guided vehicle, and a camera-based machine vision system. These all equipments are combined and form a high-tech manufacturing facility known as flexible manufacturing system, which is controlled by a host computer. Now, let us have a demonstration to understand importance and working of each equipment. It begins with ASRS, that is Automated Storage and Retrieval System. In this system, raw material and finished products are placed at its prescribed position inside a pallet. As you can see, the job along with pallet has moved through sensor-based conveyor system onto the automated guided vehicle, that is called AG. AGV is a battery-operated vehicle used to transport workload from one place to the another into the FMS system. AGV has stopped at the CNC turning center to carry out series of manufacturing operations. A robotic hand has moved to pick the job from pallet and place it into the chuck for operation. Once the job has placed into the chuck, it closes the jaw and grips the job. Now the door is getting closed and CNC machine has started performing series of operation through given set of instructions in the form of G codes and M codes through a program. First, the turning operation is getting performed using single point cutting tool. For the second operation, tool has been changed automatically from 8 tool turret and now it is performing threading operation using threading tool. Once all operation completes, door of CNC turning center gets open and job is carried out by a robotic hand and placed it back onto the pallet. After sensing the movement through proximity sensor, pallet has moved back onto the AGV through conveyor. It further moves to the next workstation, that is CNC machining center, for further operation. Over here, the job has been picked up by a 5-axis Fanuc make LR-made robot and placed it onto the table of CNC machining center. A 5-axis robot means it is having 5 joints. Each joint can move independently in a single direction, or we can say each joint is having 1 degree of freedom. Once the job has been placed onto the CNC machining center, the door has been closed and a drilling operation has been carried out through a drill tool. Just like 8 tool turret in case of CNC turning center, CNC machining center is also having automatic tool changer, which is having 6 tool to carry. Once the operation performed on job, it is carried out from machine by robot and placed again onto the pallet, which further transferred the job along with pallet to the AGV through conveyor. AGV took the finished job for inspection to check the quality of the finished job. And at last, AGV moves back to the ASRS and place the job back to its original position along with the pallet. The motive of this demonstration is to make you aware how effectively and efficiently computer-aided manufacturing has changed the conventional process planning and production planning computerized and conventional manufacturing operation automated without involving any human being into the system. Thank you.
So now moving towards the next part of the technological advancements. So this is the additive manufacturing process. Basically, there are 3 types of fabrication processes. If you want to develop your part, you can develop using 3 processes. Number 1, either you are using the subtractive processes, as we are using the conventional machines like milling machine, drilling machine, lathe machines, right? Second one is the formative processes. We are using the casting or forging process. And third one is additive manufacturing process. We can add the layer by layer parts to develop any shape of the part. So it is automatically construct the physical models from the CAD data. We just need to develop the part using specific dimensions and shape and size in any of the CAD software. We need to convert it into the STL file format, and then we can add that STL file format for the 3D printing softwares or machines. Basically, for rapid prototyping is one of the method of additive manufacturing, one of the application. So this can be achieved by using 5 different steps. Number 1, we need to create the CAD model. Number 2, we need to convert that CAD model into STL file format. Number 3, we need to work on STL file format to develop the thinner parts or the slicing. Fourth, We need to construct the object using layer by layer. Actual production is there in step number 4 using 3D printing machine. And fifth is a post-processing. We need to clean or finish the product developed using the 3D printing. So this is again a schematic process chart which represents how we can use step-by-step process to develop our concept to physical reality. Step number 1, which includes the CAD software package, or if you have a specific product in your hand, you can use the reverse engineering, you can use the laser scanner, 3D scanners, or CMM machine. In step number 2, you need to convert that CAD file into the STL file format. In step 3, you need to work on that STL file format, which is universally accepted. And you need to divide it into the thin layers. You also need to add the support material there. Fourth step, you need to use the 3D printing machine to develop the various products. The material may vary, the raw material of the different machines may vary depending upon the application. It may vary from powder form, solid form, or liquid form. And then after the post-processing, you need to clean the product developed by the 3D printer. Or you may also need to paint the product, right? There are 6 methods to develop the prototype. Number 1, SLA, stereo lithography, fused deposition modeling, selective laser sintering, direct metal laser sintering, laminated object manufacturing, and 3D printing. We are going to see first 2 methods, how these 2 methods are actually working, and we can develop the different parts of almost any shape and size. In stereolithography, it is the widely used process since 1988. It was first developed by 3D System Inc. Here we are using the raw material as a liquid form, and we can obtain the smooth surface finish. So this is the schematic diagram of the arrangement and working of the SLM. You can see in a box, one blue colored part has been generated in layers. I have one animated video which will represent how this method is actually working. Let's see.
Stereo lithography is a rapid prototyping process used to create parts from 3D CAD data in a matter of hours. SLA is a highly accurate additive manufacturing process and may also be referred to as rapid prototyping or 3D printing. Models created with this technology are typically used as concept models for form and fit studies, or as master patterns for molding techniques. The SLA process begins when CAD data is sliced into thin cross-sections or layers, typically about 0.006 of an inch thick. This data is then transferred to an SLA additive manufacturing system containing a vat of UV curable photopolymer. The machine begins to build the part one layer at a time. Each layer is constructed from an ultraviolet laser that is directed by X and Y scanning mirrors. As the laser traces the cross-section on the surface of the resin, the liquid material is hardened on contact. Once a layer is complete, The build platform is indexed down to make room for the next layer. A recoater blade moves across the surface, ensuring that a thin coat of fresh liquid resin is evenly spread over the object. The laser continues to trace and form each layer atop the previous layer, building from the bottom up. The completed part is then carefully removed from the liquid and separated from the platform. A chemical bath removes excess resin, and the part is cured in an ultraviolet oven. Any support structures are removed at this time. With numerous hand sanding and professional paint options available through service providers such as Solid Concepts, stereolithography has become an excellent economic choice for rapid appearance models. A wide variety of industries have embraced SLA, including medical, automotive, entertainment, aerospace, and consumer products.
The second method for rapid prototyping is FDM, which is widely used. Here, the filament or the raw material is of the solid, right? So it is very flexible as well as very popular. But the only disadvantage of this method is the build speed is very slow. At the same time, we can achieve the layer thickness of 0.15 mm so that it is one kind of rough surface we are obtaining. So I also have the schematic diagram of the FDM process, how it will work, and one animated video which shows the working and different components of FDM process.
Fused deposition modeling, or FDM, is a layer additive manufacturing process that uses production-grade thermoplastic materials to produce both prototype and end-use parts. This technology is known to accurately produce feature details and has an excellent strength-to-weight ratio. FDM is ideal for concept models, functional prototypes, manufacturing aids, and low-volume end-use parts. The FDM process begins by slicing 3D CAD data into layers. The data is then transferred to a machine, which constructs the part layer by layer on a build platform. Thin thread-like spools of thermoplastic and support material are used to create each cross-section of the part. Similar to a hot melt glue gun, uncoiled material is slowly extruded through dual heated nozzles. The extrusion nozzles precisely lay down both support and thermoplastic material on the preceding layers. The extrusion nozzle continues to move in a horizontal XY plane while the build platform moves down, building the part layer by layer. The finished part is removed from the build platform and cleaned of its support material. Raw FDM parts have visible layer lines. However, service providers such as Solid Concepts offer multiple finishing options to create smooth, even surface parts, including hand sanding, assembly, and cosmetic paint. Since FDM parts are constructed with production-grade thermoplastics, including ABS, polycarbonate, and Ulta, they are both functional and durable. FDM is utilized in a number of industries, including aerospace, automotive, industrial, commercial, and medical.
So these are the further applications of RP. One can develop any shape and size of material. One can develop the prototype of the particular product. This is one of the example of intake manifold. The time and the cost has been reduced to 10% of when we compare it with to the conventional manufacturing processes. So that's why RP is a very important process to convert the manufacturing into the advanced manufacturing terms. RP finds its applications into the medical applications as well. This is one of the case study I have find out from the internet, that how RP process has been used for the planning of surgical operations to separate the two twins. Further, it is also used for architecture point of view, as well as we can also develop the wind tunnel to test the various automobile vehicles as well as aeroplanes. So, as a part of advanced manufacturing process and to demonstrate the concepts of advanced manufacturing here at ADIT, we have, these are the facilities available: 3D scanner, 3D printer, and some of the printed parts you can see in this slide. Further, this is the animated videos, how the developed part looks like from various directions. These are the bearings. We can develop the bearings in a function which can function right in a various parts. We can assemble and we can use it. You can also develop any sculpture using this technology. So here in ADIT, we are exploring how the convergence of this technology trends is shaping the future of computer-aided manufacturing and vice versa, and delivering expanded possibilities to new and established users of computer-aided manufacturing. Further, ADIT College of CVM University has received the grant of 1.1 crore from AICTE to develop the facilities over here, which includes, these are the various machines: 3D printer, CNC wood router, digital microscope, CNC laser cutting machines, vinyl plotter, and electronic workbench. Further, plasma cutting machine, pillar drilling machine, mini desktop lathe. All these machines would be useful to any of the student who is studying in Gujarat region, in any of the college, any of the university, AICTE approved colleges. Then they can come to ADIT and they can use these facilities available as per the AICTE norms. Here we are providing the practical sessions, training sessions to develop to enhance the skills of the students, and we are trying to develop their mindsets to become the entrepreneurs as well as the startups. We are going to inaugurate this AICTE Idea Lab in the end of March or in the first week of the April. So whosoever are interested can communicate with us. This is the website. You can directly connect with us to utilize the facilities available in our campus. Thank you very much. Thank you, everyone. If you have any doubt or any question, you can ask so that I can reply you. Yes, Mehul sir, is there any question?
Yes, sir. Yes, sir. Wait a minute, sir. Sir, one
Yes, sir.
question about the Mr. Abrar. Which one is the best software for the part programming? Which one is the best software for part programming?
Okay. For part programming, nowadays, CAM trainer is there, right? So you can use this software. Then depending upon the application, you can also go for the sophisticated softwares developed by the various industries, various software giants, right? Any other questions, sir?
Sir, one question. Which CNC control system is based for the BMC machines? Which CNC control system is based for the BMC machines?
VMC, vertical
Yes.
CNC machines, sir. So
Which
can you
CNC
repeat the
control
question?
system? About the control system, sir. About the control system.
Okay, actually, I haven't explored the control system of the CNC system, CNC machines, so I cannot answer this question.
Thank you very much, sir.
Okay. Okay, so thank you, sir.
Yes, sir. Thank you very much, sir. And we are appreciate your being here. And thank again for the join us today. And we will see you next time for the next informative session about the CNC and another FMS or another various system of the computer aided manufacturing. So, behalf of the our university as well as the mechanical engineering department of diploma study, thank you very much, Dr. Desai sir.
Thank you very much, sir, for giving me this, for inviting me on this platform. Thank you, sir.
Once again, thank you for the Simit sir. He give the contact.
Right, right, sir.